Hello everyone, welcome back to my channel. Today let's go over a Leetcode medium question that I just solved on my own. So I'm really happy about this because I was literally struggling with this for almost a year. So I just kept coming back to it month after month and I couldn't solve it until today. I really buckled down and tried a lot of different approaches and I finally was able to solve it on my own without any assistance. So I'm extraordinarily happy about this one. I'm ready to show you, except, oh, and also this is also a similar question to a grind 75 level order traversal. So, yep, I'm ready to show you how I solved it on my own. So again, really happy about this. And let's go over it. So you're given the root of a binary tree with unique values. That helps because there are no duplicates. That makes their job a little bit easier. And basically you want to do a BFS level order traversal. So get each node level by level, level 2, level 3, level 4, and then you want to swap them, make them in ascending order, and find the minimum number of operations to do this. So if you know how to do BFS, let's get each level first. So append the root. While deck is not empty, we still have more levels to cover. This is the current level. We're going to keep each level in a matrix. Let's iterate over each level and let's pop the node from the left. And if cur is not none, then level.append the value because it has a value attribute. Otherwise, append the left child, which is 4, and append the right child, which is 3, and then keep going. So if the level exists, if there are any nodes in the level, then we're just going to append level. So let's print levels to make sure that we got the BFS correct. So this is the easy part. Obviously, if you've done level order traversal, you can do this part. But the more challenging part that I struggled with and I was finally able to break through on was the minimum number of swaps. So let's iterate over this matrix and let's ask if L is not equal to sorted L, then we have a problem because let's go ahead and say key is sorted L. So those are the levels that are problematic and that count towards this integer that we're going to return at the end. So what we want to do is let's take these two lists as an example. So what do we want to do? Well, this guy's out of place, right? It's supposed to be this. So we're just going to scan the right. We're going to find the person that's supposed to be in place. And we're going to say, okay, so we have what we need. So we're going to swap it. So swap number 1 is 5, 6, 8, 7. These two become swapped. So answer is now 1. Cool. This is still not in order. So we're going to start here again. And we're going to say to the right. Well, this one is in order. As you can see, it lines up. So this one's not in order. So we're going to go to the right and we're going to swap it and say, okay, does the one that we need, which is the correct answer, exist in the right? If it is, then swap it, right? So now we're going to get 5, 6, 7, and 8 because we swapped these two and the answer is going to be 2. And that's for this level. For this level, it's pretty straightforward. Let's copy this. So this is obviously not correct, so we're going to go to the right and say, does the right hand side have our answer? If it does, then swap them, right? And that's 1. So then 1 plus 2 is 3. So you do this for each level, and I hope this is not too confusing, but if you notice the pattern, it's not too bad. So let's do exactly that for I in range length L. At any point when there is a mismatch, if L of I is not equal to key of I, then we're going to go to the right and say, is L of j equal to key of I? If it is, then we have to swap, right? Because, for example, if we're here, or if we're here, and 5 does exist to the right of this, so swap 5 and 7 to become this and this. So L of I, L of j is L of j, L of I, and we used another swap. So let's say cur swaps plus equal to 1. Starts at 0 for each level because it resets. We want to return an integer at the end, and we just want to add C for the number of swaps it takes for each level, and then return answer at the end. So the indentation has to be correct. Let's run this. And as you can see, it passes all test cases, except this is going to be n squared. It's pretty slow. So let's wait for this to time out. Cool. So one last test case. What we want to do instead of this is keep this in a dictionary. So let's call this dict. Remember, all of the values are going to be unique, so that makes our job easier. So for I, V, and enumerate L, we're just going to map the value to the index it appears, right? And then here, what we can do is, while this is not equal to key of I, if this key of I value exists in our dictionary, which it has to because this is sorted order, if the index that this appears in, which is this is the value, you get the index is bigger than I, that means it exists to the right side. For example, that means that the one we're looking for in the current spot exists to the right of the current position. And in that case, we would just swap because we have the indexes we need. So let's call this L of I, and let's call this actually right index is supposed to be D of key of I. So in that case, Ri equals to Lri, L of I. And answer plus equal to 1, except, or C plus equal to 1. But we have a problem because now that we swap these, we have to reflect that in our dictionary, because our dictionary was originally, let's say, for example, 5 was associated with 0, and then you had 7 associated with 3. What we want that to be now is 5 associated with 3, or other way around. 5 was associated with 3, 7 was 0. We want this to now be 5 is 0, 7 is associated with 3. So how do we do that? Well, we want to keep track of the values of the keys to change. So let's call this left value is just L of I, and then the right value is key of I. Let's print LV and RV just to be sure. Okay, cool. So 7 and 5, we're looking for 5 on the right side. It exists. So now we want to change the position of the index. So let's call this, let's print I and RI. Cool. So 7 is supposed to be at 0. So now we want to basically say D of LV equals RI. So we're giving 7 3 and 5 0 instead. So D of RV is equal to I. Right. So we're just reassigning these values like this. And let's run this. And this is a lot faster because it's now O1 because of the use of the dictionary. It's n for one loop instead of n squared. So let's submit this. And there you go. Passes all test cases. Again, I'm super excited that I solved this after months and months of struggling. But again, I'm glad that I did it on my own without any assistance. So just goes to show you that it's important to come up with your own solution to problems and not to, give up too quickly and just copy the solution, because you're not going to be able to recreate that in an interview setting. If something is your independent thought, you really won't forget that under pressure, and that's really, really important. So that's it for this video. Thank you for watching, and stay tuned for more.